Let's solve this logarithmic equation. We have number 1 log base 3. The argument is 9x plus 2 equals 4. We can solve this equation using the definition of logarithm. Okay, if we have the exponential equation b to the x equals y, b is the base, x the exponent. So that is the same as, or this one is if and only if, the same as log base b of y equals x. So logarithm is, the value of logarithm is the exponent of our exponential equation. So let's apply this one. Okay, let's write this into exponential equation. So we have the base is 3, and then we raise it to the power of our exponent, which is 4, and this is equal to the argument 9x plus 2. And let's now start solving for the value of our x. So 3 to the 4th, that is 3 times 3 times 3 times 3, that's 9 times 9 is 81. And this is 9x plus 2 to the right hand side. Let's move this to the left. So we have 81 minus 2 is equal to 9x. So the left hand side will become 79. And it's equal to 9x. Let's divide this by 9, both sides. So we can cancel this out to give us x equals to 79 over 9. Okay, in number 2, you see we have sum of logarithm here. So we can use the property of logarithm, which is called the product rule. The product rule, if we have log with argument, which argument is a product, then we can express that as the sum of its factors, log base a of x plus log base a of y. So that's what we're going to do here. This is the sum. We can express this as product. So this is now log base 8, and then we can express this as product. So x times x plus x on the left hand side, and then the right hand side, just copy that, log base plus 5x plus 12. Okay, now notice that they're both expressed in logarithm both sides with base 8. So we can use the equality rule. So equality rule, if we have log with the same base, log base a of x and log base a of y, then that is just equal to the arguments x and y. So therefore we can express this as x, and x plus 6 equals 5x plus 12. You can also raise this to the power to the base from base 8 both sides, and the log of log 8 will be eliminated as long as along with the base 8. Now let's solve for x here. So let's distribute our x. This is x squared plus 6x equals 5x plus 12. Well, let's write it here. So x squared plus 6x, and then let's transpose this to the side. That becomes 5x minus 12 equals 0. That is x squared plus x minus 12 equals 0. Now let's factor this out using this method, the FOIL method. This is x and x, so that's x squared, and then the third term 12, we can express that as 4 and 3. So we have to make sure that the middle term will give us plus x. So if you multiply this, it gives you 3x. Multiply 4 times x gives you 4x. So the only thing that gives us plus x is we have plus 4x and minus 3x. So this must be minus here and plus here. So solving for x, we have x equals 3 and x equals negative 4. We can also check the value of our x by using the original equation here, but so far these are the possible values of our x. We have log. Now if you don't see a base here, that means it's 10. So the argument is 5x minus 11 equals 2. Now we can use the definition. Let's use something else, like let's raise this to base 10. We can do it like this: 10 to the log base 10 and 10 to the power of 2. That means this will cancel out. So there's going to be 5x minus 11, and 10 to the 2 is 100. Now let's solve for x. It's 5x equals 100, and transpose or add plus 11 both sides. We get plus 11 here, and let's divide 5 both sides. We have x equals, that's 111 over 5. Okay, let's go now to number 4. Now here we can use the quotient rule. Okay, the quotient rule is, we have quotient of two variables here, then we can write it into difference of the factors. Okay, so therefore you can write this into difference of the arguments inside here. But before that, let's use the power rule first, so that the coefficient of our log will become an exponent, so become a single log notation. So here we have, let's copy this one first, log base 3, that's 20x 16. Here we can write this as log base 3, 2 to the 2 is 4. Okay, and the right hand side, we'll copy that as well, log base 3 x to the 2. Now here we have difference of log, so we can write this into quotient. So we have log base 3 and 20x minus 16 divided by 4. Copy the right hand side, x squared. Now we can we can reduce the coefficients of our numerator. So this is now 5x minus 4. Okay, next is the equality rule. They are the same log both sides. So we can, or you can raise this to the base 3. Okay, and then the log will be eliminated. So we have 5x minus 4 equals x squared. And let's move this to the right hand side. It's gonna be x squared minus 5x here, so minus 5x here as well, plus 4 here, plus 4 here, so it's gonna be 0 here, plus 4. Left side will be 0. And let's factor this out. It's gonna be, okay, for 4, the factors that give us 5 could be 4 and 1. Now if you, let's find out the signs using the FOIL method. So 4 times x, that's 4x, 1 times x, that's x, and we need to have negative 5 there, so this must be minus, and minus, negative, negative, so it must be negative 1 here to give us negative x, and negative 4 here to give us negative 4x. And for the third term, negative 4 times negative 1 is positive 4, so our factor is correct. So this is now, we can now solve our x. So x equals 4 and x equals 1. So these are the possible solutions. Let's check our answer. When you do checking, you have to use the original equation. So when x equals 4, we have this, and 20x, that's 20 times 4, that gives us 80 minus 16. And this one, we can write this as log base 3. 2 to the 2 is 4. And then the right hand side is log base 3. So when x is 4, 4 squared, it's going to be 16. Or just write it 4 squared. Now, here, let's continue. 80 minus 16, that's 64. Minus log base 3 of 4. It's going to be the same here. 4 squared. Now, we can use the quotient rule. So log base 3 is 64 over 4. Plus log base 3, 4 squared. Log base 3, 64 divided by 4 is 16. And log base 3, 4 squared is 16. So that means true. So x equals 4 is a solution. Next, let's say x, let's use x equals 1. Let's say if this solution as well. So log base 3, 20 times 1, it's 20 minus 16 to, okay, let's write that log base 3 to the 4. The right hand side, log base 3 of 1 squared is 1. This is now log base 3. 20 minus 16 is 4. Minus log 4 plus log base 3. It's 1. Log of 1 is just equal to 0. And this one, log, they're the same, so it's equal to 0 as well. So 0 equals 0, that means it's true. So x equals 1 and x equals 4 are solutions of the equations.